Okay class, so now we're going to talk about Linux and DNS. So quick overview on DNS first. DNS is what matches people-friendly names to IP addresses, and in reverse. It's a standard TCP IP service, and what it does is it listens and queries its own database for these name IP associations, and it forwards requests to other DNS servers for these name IP associations that it does not know. It exchanges information with other DNS servers, and it can be installed as a service on both Windows or Linux. And there are a couple different server types for DNS. There's a master DNS server, a slave DNS server, a forwarder DNS server, a cache-only DNS server, and a stealth DNS server. To install DNS on Ubuntu, there are a couple requirements we must have set already. We must have our hosts and our hostname file already configured, and we must have a static IP address already set to our server system. Once those requirements are met, we can install DNS with sudo apt-get install, and we'll be using bind9 for our DNS service. So it'll be bind9, and we'll include bind9 utils and bind9 doc. The name of the service is bind9, and all the configuration files have named in it. So when configuring DNS, there are a number of files that you got to configure. Like I was saying, we got to have our static IP address set. We got to have our hosts file already edited and our hosting file already set up. And then we have our bind9 file that's located in the etc default directory, our name.conf file, our name.options file, and then we have our resolve.conf file and any of our DB files that we're going to edit. And then, just like we've seen with DHCP, is that all declarations must end with a semicolon. Once we have DNS installed, then we can take a look at all these files that we can edit and configure. So the first main file for DNS is the name.conf file, and this is the primary bind configuration file that points to all the other .conf files. So in this file, you'll see that it'll point to name.conf.options, name.conf.local, as well as name.conf.default-zones. We won't be editing the name.conf file, but we will be editing two of the files that it does point to. And the first file that we'll be editing is the name.conf.options file, and this is a configuration file that contains all of the global options for the bind service. You can set up the forwarders in this file, as well as configure any of the other option parameters that we have available to us, which you can look up in the bind9 documents. So let's go find this file. This file is located in etc/bind. So let's edit this file right now. We'll do sudo vim /etc/bind /named.conf.options. We'll put in our admin password, and let's go ahead and enter insert mode. So what we'll want to do is, since we want to set our forwarders up, is we'll remove this commented out section, and then we'll add our forwarders to this spot. So let's go ahead and erase the 0.0.0 and add in our system's gateway 192.168.0.1. And then let's add the UNM DNS servers 10.3.33.10 semicolon, then 10.3.32.10 semicolon. And you can add any other DNS server IP address to this list. And we set up these forwarders to ensure that when the local DNS server has issues looking up queries for name resolutions, it can forward these on to any of the servers we have listed here. So let's go ahead and just save this file now. So let's keep moving on and let's look at the next file that we need to edit, which is the name.conf.local file. So in this file is where you define your DNS zones for bind. And there are 5 common types of zones that we have for DNS. We have our master zone, which is the primary zone that is used by your DNS server. A slave zone, which is a secondary DNS server that's used for balancing. They can receive updates and information from the master zone. We have our forward and reverse lookup zones. And then we have the hint zone, which is a zone that specifies the root name servers and is denoted by a period. In this type of zone, you can send additional name resolution queries to other DNS servers that are higher up in a multi-DNS hierarchy. For example, UNAM has multiple DNS servers, and this is where you could enter in to point to another DNS server that's higher up in the hierarchy. So MGT DNS server pointing to UNM DNS server. So let's go ahead and just set up a simple basic zone. We'll edit the file. It's located in etc bind directory. So we'll do sudo vim/etc/bind/named.conf.local. In this file, you'll see that there's pretty much nothing in it. And we'll be writing the basic zone from scratch, from what we know it's supposed to be. But first, we see that we have this include statement line right here. And what this line does, if we uncomment it, it also includes the zones.rfc1918 zone address definitions. So pretty much what this include line adds is a local address zone definition for private non-internet local addresses, such as those beginning with 192.10 or 172. And since our network exists in the 192 space, let's go ahead and enable this. So we'll go into insert mode. Let's uncomment this out. And now let's build our first basic zone. So any zone always starts off with zone, then the zone's name. So in our cases, 639 ubuntu.unm.edu. I'm going to do open curly brace, close curly brace. And then you start off with your zone type. So we'll do type, and we'll do master, semicolon. And then we point to the DB file where all the information exists for this zone. And to do that, we'll do file. And the default location for all of your DB bind files is in /etc bind. Since we haven't created a DB file for this, let's just preemptively name one, and then we'll create one right after this. /etc/bind, and let's name the file db.639 ubuntu.unm.edu. And then let's end our zone definition with a semicolon. And what this zone will be used for is forward lookup. And then if we wanted to, we could add a zone for reverse lookup in here right now too. But let's keep going and let's create that DB file first. So let's save the file. So let's take a look at what files we actually have in the bind folder. So first we'll just copy over the db.local file, and we'll name it db.639ubuntu.unm.edu. Let's run that command real quick. Sudo cp/etc/bind/db.639 ubuntu.unm.edu, and we'll push enter. So let's double check to make sure that file actually got created. And we'll see that it did. So before we start editing this DB file, just a little more information about them. So these DB files are what contain all of our records for DNS. So all of our name server records, our NSs, our mail records, our web records, our host records, our aliases, our pointers. So let's go ahead and edit that DB file that we just created. Sudo vim/etc bind db.639 ubuntu.unm.edu. So in this DB file, you'll see that we have a slew of information. The important things to make note of are $TTL, which stands for time to live directive, 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 $TTL, whi which pretty much specifies the time a client retains any of the provided DNS information before refreshing it. This is listed in seconds. The 604,800 is 24 hours. But you can also list this in days, hours, and minutes. So for example, 2D3H for 2 days and 3 hours. And then we have our SOA, or our state of authority, which specifies that all of the following records are authoritative. And then we have in this zone declaration, where we can enter in our server names. So let's go ahead and do that. We'll do 639.ubuntu, 639 ubuntu.unm.edu. Because we want to use the FQDN. And then we'll replace localhost here after root with the same thing. 639 ubuntu.unm.edu. And we'll remove localhost and leave dot. And then we have a couple extra settings we have right here. So we have serial, which is something you have to increment every single time you make an edit to this file. You could choose how many numbers you want to increment it by, but as long as it's at least one, it'll be okay. We have refresh, which specifies the time interval for refreshing our SOA information. We have retry, which was the frequency for trying to contact the authoritative server. In our case, that is just this server. Then we have expire, which is the length of time a secondary name server keeps info. So if we had a multi-zone DNS setup, this is what it would use to contact a master. In our cases, we don't have to worry about this. And then we have the negative cache TTL, which is pretty much the TTL for how long a server will keep information about a request it did not find a record for, or a record that doesn't exist within this DNS server. And all these are set in seconds, besides the serial, of course. So let's go ahead and actually edit the records we have here. So we have our name server record, which will switch to our system's name. .639 ubuntu.unm.edu. And then we'll change our A record, our IPv4 record pretty much, to point to this server's IP address. So 192.168.0.10. And then we'll delete the quadruple A record since we're not using IPv6. So you might be seeing these @ symbols over here on the left hand side. And what those represent are the name server's domain name. So we could use those instead of typing out the full domain name every single time. So let's go ahead and increment our serial number by 1. And then save our file. And exit it. And that's pretty much all there is to configuring your DNS server and creating a DNS zone from scratch. There's a couple things you could do after you create this DB file. You could check the syntax of it using the sudo named-checkzone command. Then with any service role that we have installed on Ubuntu, we have to always restart the service after making any changes to it. So we just use the basic service restart command like we've been using. Sudo service, service name, restart. And then you'll be able to do any name resolution lookups. So we just covered creating a basic forward lookup zone. But remember that you can create a reverse lookup zone, but just be sure you use the in-ATA-ARPA format. And then one final best practice thing to consider is that you should set your default DNS service mode to IPv4. And this can be done in the etc default bind9 file. And just need to set the option to -4-u bind. And once you do that, it'll force your DNS server to work in IPv4 mode, which is pretty much what we need while working in the VLAB right now. And that's it for DNS.